Your AWS bill can show a sudden data transfer increase even when compute usage is flat. The important question is not simply, which service got expensive? It is, which network path started carrying more bytes? AWS can charge differently for internet egress, traffic crossing availability zones, inter-region traffic, and bytes processed by services such as NAT gateway. A deployment that changes an endpoint, a retry policy, an image pull pattern, or an availability zone placement can alter that path immediately. Treat the invoice as a symptom. Your investigation needs to connect a billing usage type to a specific time window, network resource, and workload behavior. Use Cost Explorer or the Cost Explorer API to group daily spend by usage type and region. This separates a vague transfer increase into billing categories that AWS records for that account and period. Compare both usage quantity and cost, because a rise in bytes is different from a new traffic path with a different charging mechanism. Cost data can be delayed and may be revised, so use it to define the investigation window rather than as real-time telemetry. Next, inspect the exact usage type labels in your own report and map them to the relevant AWS billing documentation. Do not assume every outbound byte has the same price or route. After locating the expensive day, inspect VPC flow logs for the affected subnets, elastic network interfaces, or NAT-related path. This illustrative record shows one interface repeatedly sending traffic to a public destination on port 443. The interface ID is the bridge to the producer. It may belong to an EC2 instance, an ECS task attachment, a load balancer, or another network interface owner. Aggregate flow log bytes by interface, destination, and 5-minute interval. Then compare that interval with deployments, batch jobs, and application metrics. Flow logs are evidence of network behavior, not a perfect billing replica, so validate their timing against the billing category. Here's a common architecture to test, not a claim about every bill. A private workload in Availability Zone B sends HTTPS traffic through a NAT gateway placed in Availability Zone A, then to an external API. The workload to NAT leg crosses an availability zone before NAT processes the bytes and forwards them outward. Depending on the applicable AWS billing rules and traffic direction, this design can combine NAT data processing with cross-AZ transfer and internet egress considerations. Confirm the actual path through subnet route tables, workload placement, and NAT gateway location. If the destination is an AWS service, also check whether a supported VPC endpoint could remove the NAT path entirely. For a suspected NAT path, query the NAT Gateway CloudWatch metric bytes out to destination over the same hourly window. A sharp increase that aligns with the Cost Explorer spike and flow log aggregates is strong evidence that this path changed. Also inspect the complementary NAT metrics and application-level request, response size, retry, and error metrics. A large response payload, a retry storm, or a new artifact download can all increase bytes without increasing request count proportionally. This command is read-only, and its output is illustrative. It does not replace invoice analysis, but it narrows the search from an account-wide bill to a specific network resource and time. Use this decision checklist. First, classify the charge by usage type, region, and date. Never optimize an unlabeled total. Second, attribute the bytes by correlating flow logs, interface ownership, CloudWatch metrics, and recent changes. Third, select the path. For supported AWS services, a gateway or interface VPC endpoint may avoid NAT traversal, but endpoints introduce service coverage and management trade-offs. Finally, evaluate availability zone placement. One centralized NAT gateway can simplify operations, while NAT gateways per active AZ can reduce cross-AZ paths and improve zonal resilience. Validate the expected traffic volume before changing either design.